Welcome all. In last lecture, we have seen the different types of multiplexers and we studied the different multiplexer ICs. Today, we will see how to design a multiplexer tree. Before that, we will see the definition which we already seen in last lecture. The multiplexers having more number of inputs can be obtained by cascading two or more multiplexers with less number of inputs. This is called as multiplexer tree. It means we can obtain 8:1 multiplexer using 4:1 multiplexer or using 2:1 multiplexer. In a similar way, we can obtain 16:1 multiplexer using 8:1 multiplexer, 4:1 multiplexer or 2:1 multiplexer, like that. Depending on the question, we will use the number of multiplexers required with less number of inputs. Now here we will see the first example in which we have to obtain 8:1 multiplexer using 4:1 multiplexer. First, we have to decide how many multiplexers are required to obtain the given multiplexer. Here we have to obtain 8:1 multiplexer using 4:1 multiplexer. So we have to use two 4:1 multiplexers for our design, so that we can get 8 inputs. 4 of first 4:1 multiplexer and remaining 4 are of second 4:1 multiplexer. This is a truth table of the 8:1 multiplexer, which consists of 3 select lines S2, S1, S0. Depending on the status of select lines, any one of the input gets selected and appears over the output, which we already studied. Now we are going to use this truth table while designing the 8:1 multiplexer. This is our design. I will tell you how this design came into picture. So we will continue with the same problem. We require two 4:1 multiplexer. I will draw over here. This is our 4:1 multiplexer first, and this is our second 4:1 multiplexer. Now these are the 4 input lines of first multiplexer, 3, 4, and these are the another 4 input of second multiplexer. Now to both these multiplexer, as this is a 4:1 multiplexer, this is also a 4:1 multiplexer, both are having two select line, that is S1, S0, S1 and S0. Here is also S1 and S0. I will short both the select lines with each other. S1 of first and S1 of second shorted together, and S0 of first and S0 of second shorted together. So this will make our S1 line, and this will be our S0 line. After that, here we have to take care that any one of the multiplexer will be enabled at a time, so that only one input can appear over the output line. This is the output line of first, this is the output line of second. So here only we have to take care that only one multiplexer should be enabled, which can be done using enable pin of both the multiplexer. Now I will connect both the enable inputs of the multiplexer through a NOT gate together. and I will make that as a third select line, that is S2. So this is how we get three select line, S2, S1 and S0. S1 and S0 are from 4:1 multiplexer, and enable line is we are going to use it as a third select line, S2, which are connected together through a NOT gate. Now if we observe the truth table, here for these four outputs, S2 line is 0, which will make enable input of first multiplexer as a 1 and enable input of second multiplexer as a 0. So as per truth table, for 4 input combinations of select line, first 4 input combinations of select line, first multiplexer will be enabled and second multiplexer will be disabled, as it has a 0 input at its enable terminal. So during when S2 is 0, we are going to get the output with respect to the first multiplexer, and for next 4 input combinations of select lines, S2 line is 1, by which the first multiplexer will get a 0 input enable input and second multiplexer will get a 1 enable input, by which second multiplexer now gets enabled and first multiplexer get disabled, by which the inputs of second multiplexer are going to appear over this output line. Now we want only one output, so I am connecting both these output through a OR gate, so that we can get any one of the output of two multiplexer on the output line Y. So this is how we can design a 8:1 4 multiplexer using two 4:1 multiplexer. This is the diagram which is drawn over here. In the similar way, we can have 4:1 multiplexer using 2:1 multiplexer. We can draw the same. I will draw over here. So first of all, decide how many multiplexers are required to construct the 4:1 multiplexer. The answer is we require two 2:1 multiplexers. So this is our first 2:1 multiplexer, and this will be, we'll draw over here, second 2:1 multiplexer. As both the multiplexers are 2:1, both will have a single select line S. I will name it as a S0. I will sort both the select lines together to make a single select line S0. Both are 2:1 multiplexer, so these are the two inputs of this first multiplexer, and these are the another two inputs of second demultiplexer. I will name them as a D0, D1, D2 and D3, which are going to act as a 4 inputs of 4:1 multiplexer. These are the again two outputs. We require only one output, so I will connect them to a OR gate. Now this will be Y1 output and this will be our Y2 output. Now again here we have to take care that only one multiplexer will be enabled at a time. So again we will connect the enable input of both the multiplexer together through a NOT gate. Which will make a select line S1. Now again there are two select lines S1 and S0. Depending on the status of select line, any one of the multiplexer will get enabled and we will get the selected output line. Now for the first input combination, if you observe, S1 and S0 are 0 0. S0 is 0, S1 is also 0. So by which this first multiplexer gets disabled, and this second multiplexer will get enabled. As S1 is 0, its enable input will get A1 input. Similarly, the S0 line is at 0, so first D0 line gets selected. We will get Y2 as a D0. As this is disabled, we will get Y1 as a 0. So the end output we will get as a D0. Again, if for the second condition S1 is 0 and S0 is 1, as S0 is now 1, S1 is 0, again this multiplexer is disabled. We will get Y1 as a 0, and S1 is 0, this multiplexer is enabled. We will get the Y2 with respect to the status of select line. Now the select line is at 1, so this D1 line gets selected. We will get Y2 as a D1. So from D1 and 0 we will get combined output as D1 over the output line. Similarly, for the third condition, S1 is now 1, S1 is 1 and S0 is 0. As S1 is 1, this multiplexer gets enabled, and through this NOT gate it will now become as a 0, so this multiplexer will get disabled. So as this multiplexer is enabled and S0 is 0, the first line gets selected, that is D2. Now we will get Y1 as a D2 and Y2 as a 0, so we will get combined output as a D2. Similarly, for 1 1, this is enabled, this is disabled. Now S0 is 1, the second line gets selected, that is we will get D3 on Y1 and 0 on Y2, as the second multiplexer is disabled, and we will get combined output as a D3 for 1 1. This is the diagram we have drawn over here. Similarly, we can obtain 32:1 multiplexer using 16:1 multiplexer. For that, we require two 16:1 multiplexer, which will make 32 lines, input lines. Both the output of 16:1 multiplexers are again connected together through a OR gate, so that any one of the output line can appear over the final output. Again, as there are 16:1 multiplexer, to each of the multiplexer there will be 4 select line which are connected together to form S3, S2, S1, S0, and enable input terminal of both the multiplexers are connected together through a NOT gate, which will make the fifth select line of our 32:1 multiplexer, as 32:1 multiplexer is having 5 select lines. Now this S4 select line will going to work as a enabling of disabling of these two multiplexers. At a time, only one multiplexer will be enabled from these two multiplexer, as I have explained earlier for the first two examples. And we will get the output with respect to the status of select line as per the functioning of 32:1 multiplexer. Again, here another example in which we have to obtain 16:1 multiplexer using 4:1 multiplexer. Here we require 4:1 multiplexer to make 16 input lines, first, second, third, fourth. After that, as we know, the 16:1 multiplexer is having 4 select lines. Now here the 2 select lines of all the 4:1 multiplexers are connected together to make S1 and S0 select line. We require another 2 select lines, that is S2 and S3. Now here all the 4 multiplexers having 4 outputs Y1, Y2, Y3, Y4, which are connected to another 4:1 multiplexer which is having 2 select lines, which will be now going to act as a S3 and S2, and we have a one output of this 4:1 multiplexer. Now here this S3 and S2 will going to pass any one of the output of this 4 multiplexer onto the final output line. So here enable terminal is not used, as we used over here another 4:1 multiplexer which will going to manage these 4 outputs as per the status of select line. You can observe the functioning in this truth table. When S3 and S2 are 0 0, mux 5 selects Y1 line, and any one of these 4 outputs will going to appear on the final output like this. Again, when S3 and S2 are at 0 1, this mux 5 is going to select a Y2 line, means the second line, and any one of these 4 outputs will going to appear on the final output line. Again, when S3 and S2 are 1 0, mux 5 select this third line, that is Y3 line, and any one of the input from D6 to D11 will going to appear on the output line depending on the status of S1 and S0. And finally, when S3 and S2 are 1 1, the mux 5 is going to select a Y4 line, and any one of the input, that is from D12 to D15, will going to appear on the output line Y depending on the status of select line S1 and S0. Now again, the next example in which we have to obtain 32:1 multiplexer using 4:1 multiplexer. Here we know 32:1 multiplexer is having 5 select lines, and to have 32 inputs we have to use 8 4:1 multiplexers, which are over here first, second, third, fourth, fifth, sixth, seventh and 8th, and these are the 32 input lines. Now each 4:1 multiplexer will be having 2 select lines. All are sorted together to make S1 and S0 line. Now as we are going to use only 4:1 multiplexer, again 2 4:1 multiplexers are used over here. The first 4 outputs of these 4 multiplexers are connected as input to this 4:1 multiplexer, and next 4 outputs of these 4 multiplexers are connected as a 4 input of this second multiplexer. Now these 2 multiplexers are having again 2 select lines which are connected together to make the select line S2 and S3. Now we are having 2 outputs which we have to convert into a single output. Now our requirement is to have 5 select line. We are having now 4 select lines. So to have a next select line, we have to use a 2:1 multiplexer which will having a select line S4, and these 2 outputs of these 4 multiplexers connected to this 2:1 multiplexer, and it will give us a final output. Now here the S4 select line is going to select any one of these 2 4 multiplexer, and this S2 and S3 lines will going to select any one of the output of this 8 4:1 multiplexer. This is how we can design a 32:1 multiplexer using 4:1 multiplexer. Again, the next example in which we have to obtain 4:1 multiplexer using 16:1 multiplexer. So to have 64 input lines, we have to use 4 16:1 multiplexer, and the 64:1 multiplexer will be having 6 select lines. So now to have a 64 inputs, we are going to use 4 16:1 multiplexers. Now each of 16:1 multiplexer is having 4 select lines which are connected together to form S0, S1, S2, S3 select line. Now out of 6 we are having 4 select lines. Now we are going to use another 4:1 multiplexer to make remaining 2 select lines, as the 4:1 multiplexer is having 2 select lines. Now these 4 outputs of 16:1 multiplexer connected to these 4 inputs of 4:1 multiplexer, which is having 2 select lines, that is S4 and S5, and this is our final output. Now here these 2 select lines, that is S5 and S4, going to select any one of the output of this 4 multiplexer and will give a final output Y of any selected input line. This is how we can obtain 16:4 multiplexer, 64:1 multiplexer using 16:1 multiplexer. Now these are the examples which you have to perform at your own. All these 3 examples are solved in the TechMax. You can refer the TechMax for designing of the multiplexer tree problems. Thank you.